Hey Pre-Calc, Mr. Rashid here, and today we are going over how to find trig ratios. And so what this means is trig ratios, just as a reminder, are things like sine, cosine, tangent, cosecant, secant, and cotangent. So those are the trig ratios. Now, what does it mean finding the trig ratios? So normally you just, if you find the trig ratio of 39.3 degrees, you would plug that into your calculator and there you go, you have the ratio. So what we're talking about here though is there's some trig ratios that we'll expect you to know, and next year in calculus they will also expect you to know these, and they're the ones that are the simpler angles that lie right on the axes. And so in this section, we'll be using the unit circle to help us identify those. And then there are a few others like 30 degrees, 45 degrees, and 60 degrees. So we can find those trig ratios too, and you'll be expected to know what those are without using a calculator. And those we will be doing in this video using special triangles. Okay, so let's get started here. So the first thing is you've already seen in the last section of this chapter where we were looking at angles, and we would identify the initial side of the angle as this marker over here, and then we would go around to some other point, and that would be our terminal side, and this then would be our angle theta. And so this is an extension. So most of the angles you've been dealing with up to this point have been just acute angles. So this is an extension that was done in the 17th, 16th centuries. And there was a point in time where physics and some of the other sciences were ahead of math, and they were interested in looking at the planets and how they rotated around the sun. And so a natural thing for them at that point, those physicists that came up with this terminology, was that we could look at the angles as where you were in terms of your position around the sun. So very arbitrarily then it was chosen here that the initial side would be over here and the terminal side would be wherever the angle ended, and that's our theta. So now the first thing I want to share is that for these, let's look at like the basic acute angles first here. So what we can do is take a point on a circle that's going around here. Now this is called a unit circle, and what that means is the radius of this circle is 1. So if I'm there, radius is 1. If I'm here, radius is 1, right? No matter where I go from the center to any point on the circle, the radius is going to be 1. Okay, so that's what the unit circle is about. R equals 1. So let me erase some of this here. So now what we can do to find trig ratios using this circle is to say, okay, here's my point, and assume this is my initial side, and then that point represents my terminal side. Okay, so we're just going to deal with acute angles first. So in this situation then, what I can say is this angle here is my theta. Now, I want to go a little bit further. I want to find what is the trig ratio for that angle there. So what we can do is, let's erase all this. We can create our point wherever we're interested in finding trig ratio. Draw our terminal side to the center and drop a straight line from that point towards the x-axis. Remember, in the last section you talked about, or you studied reference angles already. So this will help us, this little triangle here will help us figure out all the trig ratios for our theta, for our angle there. So we've taken the initial side, and that's it there, and we've taken the terminal side, and it goes straight to the center from the point there on the unit circle. And we can identify then this point as some x, y location. And this distance from here to here, from the center to the point, is 1. As I talked about, the radius of the circle is 1, so anywhere we're going is 1. Then the distance from the x-axis all the way up there is y, and the distance from the center to where the triangle ends there on the x-axis, that is x. So we've got x, y, and 1. And then we know our point is xy. So now, remember, we have sine of theta, we know is opposite over hypotenuse. So if it's opposite over hypotenuse, that's y over 1. We just write it as y. Now, if the circle had a radius that wasn't 1, of course, we would say y over r. But we can go on down the line and use our standard definitions here. So, okay, so if the circle did not have a radius of 1, we would say that it's y over r. So let's say on this slide, I'm going to make this out here and just say r for now. But on a unit circle, r is equal to 1. So sine theta is y over r, opposite over hypotenuse. Cosine theta is adjacent over hypotenuse, x over r. And tangent theta is opposite over adjacent. Then the reciprocals, so cosecant theta is y over r flipped around, so that's r over y, and secant theta is x over r flipped around, so it's r over x, so hypotenuse over adjacent, and then cotangent is adjacent over opposite, so that's got that flipped around from the tangent. Okay, so now in terms of if the radius was just 1, we would just replace all of these. We would replace all of these with the r values with 1, and then we get a simpler definition that looks like this. So sine is equal to y, and cosine is equal to x. And tangent doesn't change, cotangent is the same as before, but then secant is 1 over x, and cosecant is 1 over y. Right? We just replaced the radius with 1. So I can draw my triangle again. Let's do that here. And so this is my theta, and then this is 1 here, this is y, and this is x. Now, when we're trying to find tangent, a very useful identity is that sine theta divided by cosine theta is the same as tangent of theta. And so you can see this if I take sine, which is, let's use a y over r definition. If I go y over r and then cosine is x over r, then the r's cancel away. I'm left with just y over x. So tangent is the same as sine over cosine. That's what this rule is saying here. Okay, so cosine is your x value and sine is your y value on this unit circle. Now, one thing I kind of skipped over, and let's go back and cover that, is what if the angle's not in this first quadrant here? So remember, this is the first quadrant, this is the second quadrant, this is the third quadrant, here's the fourth quadrant. So what if it's in the second quadrant? So remember, all we're doing is we're dropping. So sure, the angle is this whole thing, right? But what I'd like you to do is get used to dropping a straight line from that point down towards the x-axis. And then the angle between the x-axis and wherever the terminal side is that goes to your point, that's called the reference angle. So that is our theta, and we can use that to find any of these trig ratios. So if I was in now this third quadrant, there is my reference angle. And then lastly, if I was in this fourth quadrant, a reference angle is going to be over there for any terminal side that ends up in the fourth quadrant. Okay, so let's do some examples here. Okay, we are going to just do some simple ones that just land on right on the axes. So remember, this is 0 degrees here, 90 degrees, 180 degrees, right? If I'm going all the way that way, 180 degrees, and this is 270 degrees. And if I make a full circle around, this could also be 360 degrees, and I could keep going. This is 360 plus 90, so this could be 450 degrees, etc. So, but many applications, they are asking just between 0 and 360, so let's leave it at that. So here's what we do. We find where does the terminal side for the angle land. So in this case, negative 180 is the same as positive 180. So let's erase some of this. So that's the same as positive 180, right? If I'm going this way or if I'm going this way, it lands in the same spot. Identify the coordinates of the point on the unit circle. So if I'm on a unit circle, then remember the radius is 1. So my distance from the center over there is -1. My coordinate there, my x value is -1, my y value is 0. So we've identified the coordinates. Now remember, we can use cosine as our x and sine as our y. So the cosine is what we need here. So cosine of negative 180 is equal to my x value in this case, which is -1. So that is basically how we deal with finding sine and cosine of angles that lie straight on the axes. You can't draw a triangle with them. Okay, so we'll look at more of this in part 2. I'll see you in a bit.